Now, since we're talking about the Industrial Revolution, it might seem odd that we're going to begin by talking about agriculture, but it's important to recognize that this is a critical, if you will, prerequisite for the Industrial Revolution. It's all well and good to have urbanization, it's all well and good to have people flocking to factories, but you can't really have a factory work or the growth of a working class if people are starving. You need to have the requisite food that they can all eat and devote their lives to working in a factory. And so I want to take you through this, which is known as the Second Agricultural Revolution. So what happened during the Second Agricultural Revolution? Fundamentally, this was a period of a revolution in the technique of farming. Don't think of it as, oh, they added tractors. Technology will come later, but that only happens after there is a revolution in technique. And so what are some of the changes? There's a more regular use of, say, manure to help fertilize the soil. Another example of this is brought about by Charles Turnip Townsend. Old practices had led, or farming practices had led to replenish the soil. Let's just leave it fallow. Don't grow anything, and that will allow the nutrients to replenish. What Townsend championed was using new crops, such as turnips, that you would plant. They would help enrich the soil much more effectively than simply leaving the land alone. You have attempts at more scientific efforts to develop better animals, more milking, all the rest of these things. And so you have generally a focus on systematized agricultural practices. How are we going to take these techniques, test them, find the most efficient ones for the most efficient growth of food production, and put those into practice? Another example of the systemized agricultural practices is the enclosure movement. Not only did people try to test what worked best, they also tried to increase the economy of scale. Landowners started to acquire more and more land and enclose it, putting fences around it to cordon it off, and allow them to take these new techniques, increase the scale, and thus vastly improve the amount of food production that they were able to do. And all of these things together started shifting farming away from simply things that families did or something that you did to survive towards a commercial venture. And I want to underscore just how transformative this is and why it's called a revolution. If you were talking about human society during much of our courses, you would be able to make a diagram of society something like, well, this, a pyramid. In that you would have the highest strata of society, the king, his scribes, the military, everything else, but everyone down here would invariably be peasants. In some societies they would be slaves, in some cases they would be serfs, all of them functionally doing farming. The ability to have social strata, social society was dependent upon having this many people involved in farming. What happens after the Second Agricultural Revolution is you do away with this entirely. In fact, you flip the script, if you will. You flip the pyramid entirely. Instead of having to rely on those, so much of society producing food, now you create our more modern system of society where a very infinitesimal number of people are involved in farming, and this allows a rapid specialization from doctors, lawyers, kings, and everything else. Indeed, the simple way to think about it is if you went to a large gathering at, say, a college or anything else and simply asked, how many of you come from a farming family, it's likely a small percentage will raise their hands. This is completely foreign to human experience, and this shift in terms of the structure of society is largely the reason that you would refer to the agricultural revolution as having such a transformative effect. All right, so what else is going on? If farming and food is necessary, how do we get towards the Industrial Revolution? If the agricultural revolution was, if you will, a prerequisite, a need, the motive for change comes from a shift away from what is known as the cottage industry. The cottage industry was a time in which people would, if you will, farmed out textile production to local farms. They would bring cloth to or raw material to farms for them to turn into small amounts of textile goods or cloth. And functionally, it was sort of a family business. Merchants would show up, they would bring some raw material, they would come back and get whatever the family had produced. This was a great way for farms to gain some income, but gradually people started to chafe under this, specifically the merchants. It didn't ensure a regular production schedule. It didn't ensure, as far as they were concerned, the most efficient use of time. And so what started to happen was factory owners or merchants started to say, well, why can't we regularize production? Why can't we organize this cottage industry, take it from individual homes and put it in, well, a very large home, a factory where we can look over people, we can manage production, we can ensure that if we own the means of production, we have the capabilities of ensuring maximum output. And so this chafing by the merchants, by the capitalists under the cottage industry is what leads to the development of a more organized factory system. Now, so this gives us the development of, or the motive drive for factories. One of the other main shifts, though, to come is, and which is necessary for the Industrial Revolution, is power sources. Because initially factories were just about organization. Bring people together and we can manage them. But eventually people started to look towards, in the textile industry, how can we improve things? How can we use machinery to improve processes, make them more efficient? And one of the ways in which people tried to make things more efficient was using different power sources. Rather than just relying on human power, let's rely on things like water power. This is why lots of early factories are located next to rivers. If you go to New England, you can see all sorts of old towns where the old factories are now shops and restaurants, but they're right on the river. That's because they needed that water power. And so for the Industrial Revolution really to take off, you need one more innovation that involves changing the source of power. And the man that's responsible for really shifting us towards that new power is James Watt. James Watt is important because what he does is he creates a steam engine, a efficient and smaller scale steam engines. Steam engines had been in existence before. He actually builds his own steam engine off an improvement of a previous steam engine by Thomas Newcomen. And what he does is he makes it possible for the steam engine to move from the coal fields where they had been used to pump out water into factories. They're now more efficient, they're now smaller, if you will, relatively portable. They're still very large, but is something that people can start to say, well, instead of water power, let's start to use steam power. And this is critically important because, as we'll talk about in our next lecture, the linkage of this steam engine to tons of amounts of coal in England is what's going to allow the Industrial Revolution really to kick off in Great Britain. And so steam power is critical because it allows factories to now be built wherever you can bring coal and to create a regular source of power that allows factories to produce more regularly and more efficiently. And it's not simply that steam power allows you to build the textile industry up and make them more efficient. You're also even able to make newer products. A good example of this is iron. Iron was not an unknown product, but it was something that was difficult and certainly expensive to produce. And this gives you a sense of how steam power enables iron to be mass-produced. You go from a period in 1740 where yearly England will produce 17,000 tons of coal to a little over a century later, they're producing 3 million tons of iron. This is a massive increase in productive capacity, and it ensures that iron can start to become regularly used in human society, in building more efficient factories, in building better equipment. It really sort of feeds on itself and produces more industry and more industrial output. And these two elements, if you will, steam and iron, when fused together, creates, if you will, the symbol of this industrial revolution. that is the railway. In this case, this is George Stephenson's invention, the rocket. This is, again, a process of improvement. You can see from the diagram, this is just a steam engine, similar to that of James Watt, just made smaller and more efficient. Stephenson designs this as part of, if you will, the X Prize competition of his day. People were saying, how can you build something mechanical that can carry goods more efficiently than a horse? And this is his design, a steam engine along rails. And what this produces is the railway, the most recognizable symbol of the Industrial Revolution. And again, all of this feeds on itself. When talking about the agricultural revolution, when talking about the steam engine, you need in all of this the capability to transport food and to transport coal wherever you need it. And thus the Industrial Revolution has now provided the most efficient means to do both of those things. And so what you should see in all of this is you're starting to get a massive increase in the development of food production. You're starting to, through that, get the ability to start to reshape how the economy works through the factory system. And steam power is starting to unlock not only more efficient means of production, but even more efficient means of transportation. And so what you should see in all of this is the Industrial Revolution is feeding upon itself and helping making it faster, more efficient, more productive. And indeed, that's probably the best metaphor for what the Industrial Revolution is. It's an engine, and once it gets started like a train, it's just going to keep moving, keep growing, keep getting stronger and faster well into the end of this course.